All right. Here's a thing pair share. And I realized that my answers at the bottom might be off by a little bit. So when I uh, finish calculating this, I may need to adjust these answers just a tiny bit. Okay. So um, when medical students all measured the blood pressure of the same person, they obtained the following results. And so we have a data set here. Assuming that the population standard deviation is 10 millimeters of mercury, construct a 99% confidence interval estimate of the population mean and write an interpretation. All right, so first let's identify information that we're given here. So let's see here. The first thing is the obvious thing. We've got all of these datums, but how many do we have? So let's see here. We've got 2, 4, 6, 8, 10, 12, 14. All right. Assuming that the population standard deviation is 10 millimeters of mercury. So population standard deviation is 10. Construct a 99% confidence interval. So that means our confidence level is going to be 99%. And if the confidence level is 99%, then that means the significance level is going to be 0.01 because these two added together will add up to 1.00. And the significance level divided by 2, so if we divide that number by 2, we're going to have 0.005. Okay, so that is about all that we got. So what do we need? What's the point of this problem? Is we're constructing a confidence interval. So that's going to be our point estimate plus and minus error. Now in this problem, we don't have our sample mean, but we do have the full data set. So from this full data set, we can get the sample mean. So to get this sample mean, we need to use our calculator to do it. And so I went ahead and went into my calculator. So we need to go to the list editor. So stat button, edit, and I put all those values in there. And this is actually the second time I've gone through this think pair share because I missed the last two numbers. And that changed my answers. So here I've got all the numbers in. So even I make the mistake of entering in data and missing some numbers. So anyway, there should be 14 because that's what we counted. On the NumWorks calculator, if we go to the statistics app and enter in all the values there. Now to get the sample mean, go up here to the tabs, go over to the stats tab and click OK. We want to scroll down until we get to not mean, which is population mean. Notice the symbol. We want the sample mean. So we get a sample mean of 133.928, 9286. Okay. And if we come over here to the Texas Instruments, we want to use one variable stats. So we hit the stat button, go to the calc menu, and we want one var stats. And we want to run one variable stats on list one because it has the data set in it. Hit calculate. And we get 133.9286. Okay. So let's go ahead and put that in. So 133.929. Yeah, we'll do that. Okay. So that comes out to 133.929. We round it to 3 decimal places. All right, so we have the X bar that we need. What we need now is our error. So error is equal to the Z alpha 2 score times the significance level divided by the square root of n. And significance level we have, n we have, but we need to get this Z alpha 2 score. So we'll go ahead and draw our distribution so we can identify this critical value. So I'm drawing a normal distribution here. It's going to be two-sided with a negative critical value and a positive critical value. So this is our positive Z alpha 2 score. This is our negative Z alpha 2 score, with the center having a value of 0. Actually, that wouldn't be X bar. Okay, it's just going to be 0. Let's just do that. All right. The confidence level is 0.99. So this center area is 0.99. And the significance level is split into two pieces, one piece here on the right and another piece here on the left. And so this is the significance level divided by 2, significance level divided by 2, and each of these areas came out to 0.005, like that. Okay, so what we need to use is an inverse distribution function in order to convert an area into a value on the number line. In this case, we want to calculate the critical value, which sets the boundary next to our significance level area. So I'm going to use the tail on the right, just because that's going to end up giving me a positive Z alpha 2 score that'll make it easier to use here in this equation. Okay. So on the Texas Instruments, I need to go to the distribution functions. So second vars button, go down to inverse norm. And I want an area of 0.005, a mean of 0, standard deviation of 1. And I want the area to the right. And let me go to the NumWorks calculator, click on Home. And I want to go to the Distributions app. I want a normal distribution, mean of 0, standard deviation of 1. And I want the area to the right. I think this is the leftover from when I did it the first time around, but put in the wrong values. Okay, I want an area of 0.005, which is going to give me 2.576. We check that here on the Texas Instruments. Okay, we're good there. Okay, so we got 2.576. So just for the sake of writing things down, 2.576. That's my Z alpha 2 score. All right, so error is going to be equal to 2.576, standard deviation of 10 all over the square root of 14. Now, I mean, I wrote down a rounded number, but I'm not going to use a rounded number in my calculation. So here, I'm just going to use my previous answer. So I'm going to hit second and then the negative key, and that'll put answer. So that's inputting my previous answer here in this calculation. And I'm going to put 10 divided by square root of 14. Now I need to hit the right arrow key twice because right now the cursor is underneath the square root symbol. So if I hit it once, it takes me out. And then I need to hit the right parentheses. And I'll leave that up because on the numworks calculator, I want to, there's two ways I can go about this. Let me go ahead and store this in variable z. Let me do that. So I'm going to hit Shift and then this orange arrow. I want to save this into variable z. So I want to do Shift Alpha Z. There we go. And let me go back home. I want to go to the calculation app. And I want to do Shift Alpha C. I think I can just put a parentheses there and do 10 divided by square root of 14. Right arrow twice to get me outside the fraction, and I can put right parentheses. And now I'll hit execute. Let's see if this works. Okay. Texas Instruments works. Okay. So we get an error of 6.884. Okay, so we get an error of 6.884. There we go. All right. So our confidence interval x bar plus and minus e is going to be 133.929 plus and minus 6.884. Let me see how that compares to what I got down here. 133.929 plus and minus 6.884. And if I do this 133.929, let's see here, 133.929 and subtract 6.88. Oops. 6.884. That gives me 127.05. 127. I'll put 0.045. That's what it was actually. And let's see here. If I do 133.929, 133.929, and I add 6.884. So I'm adding the error. I get 141.813. 140.813. Okay. All right. So yeah, that completes this think pair share. Let me know if you have any questions.